and the promise of tomorrow becomes a reality. Think you know DISD? Think again.
What's up, you guys? My name is Daryl, and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our host thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Problems together. Let's meet my student assistant for today.
Hi, I'm Jaslyn Green. I'm in this AP Calculus BC class at the Humanities Communication Magnet at Lincoln High School. I plan to attend Texas A&M University at college.
We are counting down to the calculus exam on May the 3rd. Jaslyn, how many days do we have to prepare?
Let's get ready to rumble!
Our first caller is Clifton from Lincoln.
Hey, Clifton.
Hey, how you doing?
Hey, do you see anybody you recognize?
Hey.
So you said hi. You see all of our paraphernalia here? Can you tell Lincoln's in the house?
Lincoln has something they want to say.
What do they want to say?
Hey, baby, this Bobby.
Excellent. You ready to work a problem?
Yes.
Hello, everybody. Let's go. You ready? Here comes the problem just for you. Can you see that? Let me help you. The second derivative is less than 0.
Whoa!
If the second derivative is negative.
Then the original function is concave down.
All right, I'm going to make a note. Concave down. That's good information. The first derivative is 0. What does that tell you?
That there's a horizontal tangent.
Oh, good job. and the value at 0 of the function is greater than 0. What does that tell you?
That is greater than 0.
That's right. The value is greater than 0. So like the y value is, what could it be?
Positive.
That's right. It's positive. All right. Pick the picture that has all of those qualities. Can you see? Let me move it over just a little. You're looking for concave down, a 0 tangent line at 0, and the value of the function is positive. What do you pick? A, B, or C?
It would be B.
It would be B. Let's check out all the criteria. Is this function concave down? Yes, it is. Is there a horizontal tangent line at 0? And is the value of the function positive at 0?
Yes, it is.
All three yeses. You did a great job, Clifton. Thank you for calling in. You want a round of applause or a bell? All the above. Who's our next caller?
Our next caller is Marima from Molina.
Hey. Hey, is that ice cream melting?
Excuse me?
Melting?
Not yet.
Not yet. Good. Well, we better hurry then. I'm going to put your picture up. Is this you?
Yes.
Mariama?
Marima.
Say it again.
Wow, you look pretty cool.
Yeah, baby.
Calculus smart. I've got a problem for you. You ready?
Yeah.
Okay. Which of the following functions is continuous but not differentiable at x equals 0?
Okay.
We'll examine each one, okay?
Okay.
So the first one is x to the 1/3, or the cube root of x. What do you think about it? Is it continuous at 0?
Yes.
Wow.
Yes, it is.
That's pretty
Is it
heavy.
differentiable? Does it have a derivative at 0?
No.
Very good. So this one's a no. So, I mean, actually this is a yes, isn't it? It meets the criteria. It's continuous but not differentiable, so that's a yes. What about absolute value of x?
Yes.
That's a yes as well. Continuous but not... All right, tell me why this one's not differentiable. What's going on?
There's a sharp turn.
Very good, a sharp turn. Y equals x squared, continuous but not differentiable.
No.
No, it's continuous and differentiable. So what would you answer?
1 and 2.
1 and 2 is perfect. That's exactly right. You did a good job with that. You analyzed each one and you figured out, and I almost went backwards for a minute. I had to stop and think. Continuous but not differentiable is the correct thing you want. Hey, thank you for calling in. You guys call back, okay? Enjoy that ice cream. You're welcome. Who's our next caller, Jasmine?
Our next caller is Brittany from Skyline.
Hi, Brittany. Oh, you're a non-picture person?
Yeah.
Okay, that's all right. Are you AB or BC?
AB.
AB, excellent. I have a problem here for you do you like fundamental theorem of calculus?
Yes.
I do too. This is one of those problems that if you get it, boy, you got it good, right? Brittany, have you got it good? What do you know about this problem? Can you read it okay?
Yes.
Derivative of the integral.
Well, the d over dx and the integral cancel out.
That's right, they cancel each other out. They're like they're inverse operations, aren't they? So what do you do to get the right answer?
So that's your final answer.
3 sine e to the 3x, right?
You're exactly right. It's sine of e to the 3x with a chain out 3. And you started with that. You knew exactly what to put. You will get that right. This is a low-performing question on the test.
Cool.
Get it right. You're ahead of the game, aren't you?
Uh-huh.
Excellent. You did a wonderful job with that. You're back, okay? All right, Brittany. Bye-bye.
Bye.
Who's our next caller?
Our next caller is Yvette from Sunset.
Yvette?
Hi.
Hi. You got your picture? Are you number 1, Yvette?
Yes. Yeah.
All right. You're number 1 in our picture gallery, aren't you? Excellent. I like the way those shadows are going. That is
Wow,
excellent.
you look pretty cool.
Yeah, Ms. Bazinski.
Ms. Brzezinski did that. That's right. So what's going on over at Sunset these days? Y'all having fun?
Oh, yes. Calculus.
Just calculus, calculus, and more calculus, right?
Yeah.
Couldn't have any more fun than that. All right, here's a problem for you. This is like one of the real-life questions. It's been on a real-life test, right?
Wow,
A curve
that's
has
pretty
a
heavy.
slope of 2x minus 3 at each point on the curve. That's the slope. What else would we call that? What do we call the slope?
Is derivative?
Yeah, we call it the derivative. Write an equation for this curve. We're looking for the curve if it passes through negative 1, 5. So where do you want me to start?
We're having.
Are you having a fire drill?
Yes.
Do you need to leave?
I don't know.
No.
I don't want y'all to get hurt. Y'all want to call back?
Sure.
Okay, you call back and we'll finish that problem later, all right?
Okay.
All right, good luck on that fire drill. That's a first. I don't think we've ever had a fire drill before. Yvette, what do you do for fun on Saturdays? Yvette, I'm sorry, I called you Yvette. Jaslyn, what do you do for fun on Saturdays?
On Saturdays, I have my peer tutoring calculus where I tutor my peers.
You tutor calculus on Saturdays.
Yes.
That is a lesson for us all, isn't it? Isn't that wonderful? So do people pay you?
No.
You just do it out of the goodness of your heart.
Yes.
That is-
Maggie from Adamson.
Hey, Maggie.
Hi.
How are you?
Here's Johnny.
I enjoyed visiting you guys this week. I like your rooms. Those are really new, aren't they?
Yes, they are.
Kind of snazzy looking. All right, I got a problem for you. Who's coming on the show next week from Adamson?
Maria.
Maria, that'll be great.
Excellent.
Okay, this is the graph of f prime. That's hard to see probably, but I'm going to write it bigger. F prime, F prime, F prime. What is this the graph of?
Of F prime.
Exactly. We got to keep that in our brains, haven't we? Which of the following statements are true? Okay, can you see it all right?
Yes.
And it's crossing at 0 and 2, and this is f prime. The function, I just said the function, right, is decreasing for x is less than 1. The function is decreasing for x is less than 1. True or false?
False.
That's right, false. Where is this function decreasing? Where the derivative is?
Negative.
Here and here. Good job. The function is concave up for all x between 0 and 2. True or false?
False.
That's right. Where is the function concave up?
Concave. From there
From over here
to 1.
to 1. Oh, now how do you know that? How's that about concave? You're exactly right. Tell me what that means.
Because it has a positive slope.
That's right. So f double is the slope along here, right? And it's positive. Good job. F of x has a relative minimum at x equals 2. If this is the derivative, is that a minimum on the function?
It's a maximum.
Exactly right. It's false because it's a max. The derivative is positive then negative, so the function is increasing then decreasing. That's a max, not a min. So which of the following are true?
None of them.
None of the above. That's right. None of them are true. Okay? Hey, you did a good job. Listen, thank you, Maggie, for calling in. You guys call back.
Okay, bye.
Bye. Jaslyn, who's our next caller?
Our next caller is Evante from Lincoln.
Hey, Avante.
Hello.
You are the luckiest person I know. You win all the time, don't you?
Oh.
You win these prizes all the time, don't you? Yeah, I know. You do try. You do a good job. Have you been playing soccer this week?
You do too.
Thank you. You've been playing soccer?
Season over.
Season's over. Oh, pardon me for not knowing that. What season are we in now? Help me out here.
We're in calculus season.
We're in calculus season. That is the best answer.
Right now we're working on them slopes.
That is the best answer I've heard in a long
Isn't that right, J-Mac, them slopes?
Slope? Slope is a good thing to work on. All right, I got a problem for you here that's got a lot of words in it. Let's see if you like words. You like words? If f of x is x squared minus 4 over x squared minus x minus 2, which of the following are true? Now, let's look at the kind of questions, Evante. Something about vertical asymptotes, vertical asymptotes, vertical asymptotes. Does that give you a clue of what you need to look for?
A hole.
Yeah, you need to look for a hole in the graph or a vertical asymptote. Very good. So how are you going to look for that?
You want a factor?
All right. Tell me what to write.
X minus 2 on the top.
X plus 2x minus 2 on the top. That sounds perfect.
On the bottom, X minus 2 and X plus 1.
That is exactly right. So what have you found as you work this problem? What have you discovered?
It's a common factor, which is X minus 2.
That's correct. So what does that tell you?
That's a vertical asymptote or a hole.
Ah, which is it?
Oh,
If it removes,
hole.
it's a hole in the graph. You've got a hole in the graph at x equals 2.
yeah.
And it does remove itself if you want it to. That's right. So that's a hole in the graph, not an asymptote. See,
Okay.
they were hoping you'd think it was an asymptote. So what is the asymptote?
X equals -1.
All right, x equals -1. So let's go through and see. The first one says x equals -1 and 2 are asymptotes. So you want to say no to that one, right?
Correct.
Then the next one says y equals 1 is a vertical asymptote. That's crazy talk, isn't it?
Yes.
Y equals 1 is the what?
That's a horizontal line.
That's right, so that's not true. And then the last one says the line x equals -1 is the only vertical asymptote. What do you think?
That's correct.
That's correct. So you had to be sure though, because a lot of students will see this and they won't notice and they'll think, oh, I've got 2 vertical asymptotes, and they don't have. And that's usually choice A.
Alrighty
We call that the sucker choice, don't we? All right, Ivante, thank you for calling in. You guys call back.
All right, goodbye.
Bye-bye. Who's our next caller?
Our next caller is Jose from Molina.
Hello?
Hi, who is this?
This is Kimil.
Kemuel from Carter.
Yes, ma'am.
Hey, we're glad to hear from you, Kemuel. How's everybody doing?
I'm sorry.
How's everyone doing? Good, good. Say it again.
I said we're doing alive and well.
Alive and well. I get it. I guess I'm just all clogged up today. Here we go. I got a problem for you. You ready?
Great.
Kemuel, uh-oh, the machine's gone crazy. I'm better now. All right. Do you see what it says? Can you read it?
Yes.
Integral from 0 to pi over 3.
Okay.
Is that making you dizzy?
All right, I can see that.
It's making me dizzy. Secant squared of x plus cosine of x dx. What do you need to do to that problem?
Looks like we're doing integrals.
That's right. We were going to integrate. What would I put? You tell me what to write.
We're going to put tan x minus sine x.
Tan x minus sine. You did that very quickly and very confidently.
Yeah.
I like that. Now let's see if you're right. Is he right? Jaslyn, do you think he's right? Tan of x minus sine. Jaslyn says you're right.
Except for
Change that
the
minus to a
sign.
plus.
Oh, Jaslyn caught that too. There you go. That's better. Now let's see if we're right. The derivative of sine is cosine, so yes, we're okay
Sorry
now.
about that.
That's okay. We all have those little blips in the road of life. Now what?
All right. Now we're gonna sub in the b minus a.
All right. Tell me what to write.
No, but tan pi thirds plus sine pi thirds.
And we hope we know what that is, right? We're thinking we know. Okay. Take away what?
0.
Yeah, that's
tan
right.
of 0.
Tan of 0 and sine of 0 are both 0. So we're okay with that, aren't we?
Yeah, we're
We
just
have to
fine.
think about it, though. All right, now comes the good part. The tan of pi over 3 and the sine of pi over 3. Which one do you like best?
I'm sorry, what was that?
Which one of these do you like best?
Do I like this?
Uh-huh. Which one do you want to do first?
I kind of like the sine of
I kind of like the sine, too. What is the sine of pi over 3?
It's 1/2.
Is it really? Jaslyn, is the sine of pi over 3 1/2?
No.
Oh.
Oh, they laughing at me. They laughing at me.
Oh, no.
Laughing at
Hey,
me.
they're laughing with you.
Oh, okay.
All right, they're
I
laughing.
got it mixed up. It's
That's okay. We all get them mixed up. What is the sine of pi
square root
over
of
3?
3 over 2.
That's great. And you want to think about it and be sure you're right on the exam to make sure you don't mix those up, okay? All right, now what about the tan of pi over 3?
Tan of pi over 3.
It's the sine over the cosine. So do you know what that would be?
Square root of 3.
That's exactly right. And you know what? I think that's a really good answer. What do you think?
Yeah, I think so too.
You know, they might make you get a common denominator, but I personally like this answer very much. Now, be sure and work on your trig values to make sure, and I'm talking to everybody, make sure we get those right, because, you know, I bet you money they'd have 1/2 as a choice, don't you?
Yeah.
Yeah, they're going to have that. All right, listen, thank you for calling in. You guys call back.
All right.
All right. Jaslyn, who's our next caller? Looks like we've lost some of our signal here.
Yeah. Our next caller is Hector from Sunset.
Hey, we got Hector. Is this Hector? Hello? Do we have Hector on the line?
Yeah.
Hey, Hector, how are you
Hello.
doing?
I'm doing fine.
I'm I'm gonna show your picture.
Oh man.
Oh man, here it comes. Ready or not?
Oh.
Well, we're getting ready to show your picture. I'm gonna have to describe you in a minute.
You can ignore the picture.
Oh no, I don't like to ignore the pictures. There may be a Hollywood scout out there looking for a good-looking movie star.
You won't find one here.
There you go. There you go. Just in case they're looking for a good-looking guy, then here you go. Thank you, Hector. I appreciate you calling in. All right, Hector, I've got a logarithm problem. Do you like logarithms?
Excuse me?
Do you like logarithm problems? Yeah, maybe not.
Yeah.
The natural log of 3x plus 5 plus e to the negative 2x, and I'd like the
Whoa!
Yikes. Do you know what to do?
Yeah.
Okay.
Wait, I can't. Yeah, one over. Isn't it going to be the derivative on top and the function on bottom?
That's exactly right. The derivative on top and the function on the bottom. So let's do the easy thing. Let's write the function first. So what do I write down here?
Oh man, I can't see that.
Can you see it?
3x. 5
plus 5
plus
Yes.
e to the what?
negative 2x. Yeah, I know that's a little hard to see.
Yeah.
Is that better?
Yeah.
Okay, and now I want you to see what you can
Okay.
do about the derivative part. That's what you need to take the derivative of. So what do you know for sure?
Okay. The derivative of 3x is 3.
3x becomes 3. Good. Plus 5 becomes
0
0.
plus negative 2 e to the negative 2x.
That is perfect. 3 plus or minus, you can just say minus if you want. 3 minus 2 e to the negative 2x. You did the chain out beautifully. The derivative of e to the u is e to the u with a chain out of the derivative of what's up here.
Yeah.
Perfect. That is a great answer. That is a good problem to know how to work. I think they'll ask one like that, don't you?
Yeah.
All right. Thank you for calling in.
Right.
You guys call back. Who's our next caller, Jasmine?
Our next caller is Jose from Molina.
Hey, Jose. Is this Melina?
Yeah.
I hear Ms. Brzezinski redecorated the room. Is it looking really fabulous?
Nah, still looking the same.
Well, it always looked fabulous. That's the correct answer, Jose. Is this you?
Yeah, man.
All right, there we go. Looking very calculus smart.
Wow, you look pretty cool.
So what have y'all been studying this week?
Oh, volume, the disc.
Oh, volume's the disc. All right, that's pretty cool. Well, let me see what I've got here that you might like. Oh, I've got a problem I would like you to work using a calculator. Would that be okay?
All right, let me get a calculator.
All right, you get one, and I'm going to get mine ready too, so we can. I think I've already typed it in, so I have that much done for you. Let me go through the problem with you. And it's kind of the typing got close together here. I don't know what happened. The first derivative is 8 cosine x over x squared minus 1/8. That is the first derivative, okay? On the interval 1 to 10, I'd like to know how many relative max, relative mins the graph of f has, okay?
All right.
So that's what we're looking for. This is the first derivative. So have you got it in your calculator?
Yes, I'm punching it in.
All right, you punch it in before I'll pull that off and put my calculator up in just a second. 8 cos of x over x squared minus 1 over 8 is the derivative. So we're looking at the derivative, true?
Yes.
Do you know what to look for when you're looking at the derivative? What are you looking for to find max and
Zeros.
mins?
Zeros.
Zeros, that's exactly right. All right, I'm going to move this off and put the calculator. Let's see if we can make it where you can see my calculator screen. Ooh, it's dusty. Let me clean it. All right. It's still a little dusty, but anyway. All right, I've got mine. Does it look like I typed it in okay? 8 cos of x over x squared minus 1/8. What do I need to check if I'm a calculus student? What do I need to check first with a function that's cosine?
The mode.
The mode. Am I in the right mode?
Yes.
Yes, I am. What do I need to be in?
Radian.
Radian mode. Very good. Second quit, and I'm going to go back to my y equals screen. All right, they gave me a window. They said 1 to 10. So what do you want to set your window for?
Oh.
1 to 10, right?
Yeah.
And this might have been negative 3, 3. I'm going to put it like that first. All right, now I'm going to go to the graph screen. And you told me you're looking for zeros.
Yes.
Can you tell what's going on right there? That's a little hard to tell, isn't it?
It looks like it's going up and then
It
comes
does.
back
So
down.
here's what we can do to be sure. Let's go in and close this down to negative 0.5, where we're not looking at so much of the graph, so we can really, oh, see, you were right.
Yeah.
It's going up and then back down again. So we have zeros, 1, 2, 3. What does that tell you about max and mins for the function?
Two
Two
maxes.
what?
Two maxes.
Two maxes. Because the first derivative is positive to negative, this is a max, and that's a max, right?
Yeah.
What's this point right here?
That's a min.
That's a min. So what's your total answer? You have what and what?
Two maxes and one min.
Excellent. Let's write that down. There are two
Relative maxes
relative max.
and one relative min.
Very good. And one relative min. That wasn't too hard, was it? As long as we knew what we were looking for.
Yeah.
And this is what we're looking for. If this is the first derivative, positive to negative means function has a max. Negative to positive means function has a
Min.
min. Good job. You did a beautiful job. That looked kind of messy, but it's not too bad to type in the machine, is it? Don't
No.
forget radian mode. That's really important. Every year, some students take the whole test in the wrong mode. Isn't that sad?
Yeah.
That would be really sad. Hey, thank you for calling in. Let's have some bells for that. That was a good problem. You did a good job. Who's our next caller,
Our
Johnson?
next caller is Gabriel from Spruce.
Hey, Gabriel.
Hello.
Hi. How's everybody at Spruce?
We're good.
Excellent.
Hello, everybody.
Who's your teacher?
Miss McMullen.
Miss
Best teacher of
McMullen.
all.
I was just wanting you to say it out loud. Did you say it out loud?
Miss McMullen.
Ms. McMullen. I know Ms. McMullen. We're partners
That's a little
in
joke.
crime, aren't we? We both work in the Crockett Building. All right, let's see if I can find you a really good problem. I'm looking for a fabulous problem. How do you like integrating? Do you like integration?
Yeah, I love integrating.
All right. Here we go. Can you see it? It's kind of, my machine's kind of wobbly today. Find the antiderivative of that. Well, what does that mean?
You gonna take it back to the original problem?
Okay, tell me what to write.
First, I would rewrite the problem.
Okay.
X, in open parentheses, x squared plus 2 to the 1/2.
I like that. Now what?
And then I pull out a u, which is x squared plus 2,
Okay.
and take the derivative, and the derivative u du, that'd be 2x dx,
Good job.
and then solve for dx.
Okay. And what would that give me?
So u over 2x plus dx.
Okay. Now what? That looks good.
And I back substitute the u into the column.
All right. Tell me what to write.
X and open parentheses u to the 1/2 and du over 2x.
This is going to work out nice, isn't it?
Yeah.
Now what?
So you cancel out the x's
I'll smear them out, okay?
and you can pull out the 1/2.
All right. Can I put my integral sign? Go ahead.
Yes. Alright.
Is that okay?
Yes, ma'am.
All right. 1/2 integral of u to the 1/2 du. Now you're ready to integrate, aren't you? Now you're ready to integrate, aren't you?
Yes, ma'am. Okay. Add 1/2 to the exponent.
And what would that?
Add 1 to the exponent.
Perfect. What would that be?
3 over 2.
Excellent.
And then divide 3 over 2. We just flip and multiply 2 over 3.
All right. Let me catch up with you. You're getting ahead of me. That's good. All right. What else?
Let's see.
Plus C. Good job. Now, what else do we need to do? This is great. You're doing a great job.
Good answer.
Put together like terms.
Okay. You want to cancel that and call it 1/3?
Yes, ma'am.
That sounds perfect. What am I going to put in place of u?
The 2x, what's used of the x squared plus 2.
X squared plus 2, right?
Yes, ma'am.
Is that what you said? You did a great job. Look at that. That was a hard problem, and it looks like you did a really good job. Came out really well, okay?
Okay.
Hey, listen, thank you guys for calling in. You guys call back. Y'all are going to do well on that test.
All right, we will.
Okay. Bye-bye.
Bye.
Thanks. Who's our next caller, Jaslyn?
Our next caller is Kristen from Adamson.
Christian from Adamson. Hey, Christian. How are you? Fine. Did y'all work hard that day after I left? You look like you were working very hard.
Yes.
Just no breaks for you, right?
No.
Just working.
Oh, yeah.
That's good. Y'all going to get those 5s, aren't you?
Yes.
All right. Are you an AB student? You're AB, right?
Yes.
Are you a junior or senior?
Senior.
Senior. Where are you going next year?
I'm still thinking about it.
That's okay. You got time. Well, let me know when you decide, okay?
Okay.
All right, look at this. Integral of 1 over e to the 2x dx.
Oh, let's rewrite it.
Okay. What would you like me to write?
E to the negative 2x.
Perfect. E to the negative 2x dx. Now what?
And then we have the u is negative 2x.
That looks good.
The du is negative 2 dx.
Okay. Then what do you do?
And then we can put a negative 1/2 at the outside of the integral so we can cancel the dx to put just du.
Perfect. So you like to put a negative 1/2 out front to compensate. Do you want me to call it e to the u or what?
Yeah. Du.
du. I like that. That is perfectly good. You didn't have negative 2 dx, so you divided over here. You said, you know what, I can put that out front. That's great. Now what?
Now we can take the integral. It's negative 1/2 e to the u e to the negative 2x.
And don't forget, let's see. Hey, that is beautiful. We need a couple of bells here. Good job. Great job. You guys call back.
Okay.
Thanks.
Okay, bye.
Bye-bye. Jaslyn, who's our next caller?
Our next caller is Crystal from Carter.
Hey, Crystal.
Hi, how are you doing?
Hi, I'm doing fine. How are you doing?
I'm doing fine.
You AB or BC?
AB.
AB, excellent. So y'all got a big group there taking AB?
Say it again.
You got a big group of kids taking AB?
We sure do.
Excellent. That's good to hear. All right, I've got it. Do you like implicit differentiation?
Sure.
Of course you do. That is the perfect answer. Yes. All right. Consider the curve. This was actually out of 1992. That's probably before you were born, right?
Uh-huh.
Yeah. But it was a question they gave AB4 and BC1. So it was a question they used, and you never know. They like these questions. It might come up again, this kind anyway. Y plus cos of y equals x plus 1. And we're looking from 0 to 2 pi. We want dy dx. What do you need to do?
Okay. You write the equation then.
Okay, tell me what to write.
Y plus cosine y equals x plus 1.
Good job. Now what do you do?
And then you're trying to find the derivative in terms of y.
That's right, dy dx in terms of the derivative with y left in. We're going to have y language in the answer is what they're telling us. Okay, so derivative of y with respect to x, just like we usually do. So what's the derivative of y?
It's y squared, well, 1/2 y squared. Oh, dy over dx.
Yeah, that's pretty easy, isn't it? Dy dx plus, what's the derivative of the cosine of y?
The sine y.
Is it sine of y?
Sine.
Good job. Sine of y what?
Dy over dx.
Perfect. Equals, what's the derivative of x?
1.
And the derivative of 1 is 0. Great. Now we need to do what with the dy dx?
Move it to the other side.
That's right. Factor out okay with you?
Yes.
All right, tell me what to write. When I take dy dx, what's left?
1.
Good job. A lot of people
One
think there's
minus
nothing left. There's a 1. What's left when I take out dy dx?
Sine y.
I have to write little because I didn't make enough room. Equals 1. Okay? So how am I going to get dy dx?
You just divide.
Perfect. Divide by what?
1 minus sine y.
Hey, you know what? Good job. That is exactly right. They told us it would be in terms of y, and it is. I think they were just warning us so we wouldn't be scared, right? You weren't scared, were you?
No.
No, you knew exactly what to do. Hey, good job. That is very good. Knowing how to do those problems is really important. Knowing how to do an implicit differentiation. It's going to stand you in good stead. Who's our next caller, Jaslyn?
Our next caller is Antoinette from Lincoln.
Hey, Antoinette.
Hi.
You know anybody out there?
Yes.
Did you say hi?
Hi.
We're all saying hi. I'm glad you
Hello, everybody.
Antoinette, I got a problem for you here. Let's see if I can get my machine to not act crazy. H of x is cosine squared of x plus sine squared of x, and I'd like the derivative. What do you think it is?
Negative sine x.
Cosine squared of x plus sine squared of x, and I'd like the derivative. Can you read it? I know it. The machine's acting crazy. I promise I'm not doing anything.
0.
Ah! How did you know that?
That's one of the identities.
That is an identity. What is cosine squared plus sine squared equal to?
It equals 1.
It's equal to 1, and therefore what's the derivative?
0.
I thought you might try to take the derivative, which you could actually do, and you get the same answer. Did you know that?
I knew that.
That saved you a lot of work, didn't it? Knowing your identity paid off, right?
Yeah.
That's kind of like they're trying to trick us, isn't it?
Yeah, it really do look like that.
It's a little trick, but that's okay. We don't mind. You did well. That was really good. Let's have a bell here. Thank you for calling in. You guys call back. Who's our next caller,
Our
Jackson?
next caller is Angel from Skyline.
What?
Hi, Angel. How are you?
Oh, fine.
Are you in Miss Johnson's class?
Yes.
Hello,
Let
everybody.
me show your picture here. Hold on. I got to get you framed just right, okay?
Okay.
All right, here we go. Miss Johnson's class. Are you her top student?
No.
No. It's okay. You can say one of the top. Good job. Thank you for sending those pictures in. Thank you for doing that. All right. Are you an AB student or a BC?
AB.
AB. All right. Let's see if I got a problem here. Let me get my machine back to normal, or as normal as it gets. I've got a problem here for you. Let's see how you like it, okay? It's an integration problem. Do you like it?
Sure.
Sure. I do too. I like this problem. Tell me what to do. Don't let that E stuff bother you, okay? That's not bothering you, is it? No. Just focus on this part first.
U prime over U.
Very good. You think it's U prime over U. Well, let's see. If U is x squared plus 1, what is du?
2x.
2x dx.
dx.
How do you fix it? Just tell me what you do. Different schools do it different ways.
Multiply by 1/2.
That's right. If you need a 2 here, so you have 1/2 out front. All right. Now it's the integral of du over u, just like you wanted it to be. Oh, sorry, got off the screen. Now, let's change our limits. Do you mind doing that while we're at it?
Natural log of E.
Oh, well, hold on.
Oh, U, I mean U.
You're just way ahead of me, okay? Slow down just a minute. Let me catch up, all right? If 0 is plugged in here, what do I get for the limit? If 0 is plugged in here, I get 1. If the square root of e minus 1 is plugged in here, what do I get when I square it?
E.
E. Very good. That's exactly right. Okay, now you continue. You were telling me the right thing. 1/2 what?
Natural log of U.
Perfect. Natural log of u with some plug-ins. True?
Yeah.
All right, let's plug them in. What do you get?
1/2 natural log of E minus 1/2 the natural log of 1.
Will that answer be down there on a multiple choice?
No.
No, it won't. What is natural log of e equal to?
1.
That's right. This is a 1, so we've got 1/2. What is natural log of 1 equal to?
0.
So we've got 1/2 take away 0, which is? 1/2. Hey, good job. I like the way you did that. Round of applause. That's good. I like the way you did that. You held that very well. Thank you for calling in. Who's our next caller?
Our next caller is Braulio from Molina.
Hey, Rolio. Let me show your picture. Is that you? Are you there?
Yes.
Rolio?
Hello.
Hi. Tell me how to say your name.
Braulio.
Braulio. Okay, I'll try to get that straight. You know, somebody called one week with an alias. Can you believe that?
Cool.
Yeah.
You guys wouldn't do that. Y'all wouldn't call with an alias, would you? All right, here we go. I've got a problem for you about continuity and differentiability. Do you like those?
No.
Oh, well, good. This will be fun. Yay. All right. Find A and B. See how A and B right here? So that the derivative at x equals 3, that's the critical place where this thing's falling apart, exists. Now, if the derivative exists, what also has to happen?
That's pretty heavy.
Has to be continuous.
That's correct. So you're going to deal with continuity and differentiability. So how am I going to see about continuity? What am I going to do to check continuity?
You have to plug in the 3.
That's
the
right.
square.
Plug in 3 in both places. Tell me what to write.
3 square.
3 squared needs to equal what? Plug in
3a plus b.
3a plus b. That's right. What is 3 squared?
9.
9 equals 3a plus b. Good. That's the continuity issue. Now let's talk differentiability. What's the derivative of x squared?
2x.
What's the derivative of ax plus b?
A.
And these have to also be equal at what point?
3.
That's right. So what do I write?
2x equals a.
And what's x equal to?
3.
3. So 2 times 3 is how much?
6.
You already have a. Yay. Now how do you find b?
Yep. Plug in the 6 for the a.
All right. And what do I get? 9 equals 3 times 6 plus b. What's b equal to?
-9.
Very good. I got carried away there. So b is -9. Good job. You did a great job. Sometimes they'll say, what's the sum of a and b, just to make sure you're really working the problem, okay?
Okay.
You did a great job. Thank you for calling in. Extra bells. Oh, I think the tiger got in my bell. There we go. Who's our next caller?
Our next caller is Alberto from Townview.
Hey, Alberto.
Hello,
Hi. Who's your teacher?
Miss Ada.
Miss Ade. Excellent. Miss Ade sent me a picture. One of your students sent a picture. Wasn't you, though, was it, Alberto?
What?
It wasn't you that sent a picture, right?
No,
I forget who it was. Do you remember who it was?
Frankie.
Frankie. That's right. It was Frankie. I knew that on a good day. All right. Let's see what we got here. Let's try this problem, okay? You get where you can see it. Okay, Alberto. I've got the limit as h goes to 0 of f of 5 plus h minus f of 5 over h is 2. Well, what statement of the following must be true? Do you know what this is telling you?
The definition of the derivative,
That's right. It's the definition of the derivative. The derivative of what?
5.
The derivative at 5 is 2. So this one's true, isn't it? That's definitely true. True?
Yeah.
Okay. If a function has a derivative, what else is also true? At that point, it must be.
Continuous.
That's right. That's also true. Now all we have to deal with is the first one. Is the limit of the function as x approaches 5 going to 2? How would we know, right? All we know about is the derivative and the continuity. We don't know the limit of the function going to 5, do we? Not in the least. All we know about is the derivative, which also tells us continuity. So which ones are true?
2 and 3?
2 and 3. That's very good. Do you like that problem?
I don't know.
Yeah, me too. Hot and cold, lukewarm. I like it, actually. I think it's a good problem. And I think you might see it on the test. So you can practice on that, okay?
Okay.
All right, listen, thank you guys for calling in. I heard y'all had a big prep session Monday. Is that right?
I couldn't hear you.
Did you have a big prep session on Monday that y'all worked extra hard?
Yes.
Did you go?
No.
Oh, no, you're going to have to make up time to miss A-Day, right?
What?
All right, thank you for calling in. Extra bells. Here's our next caller.
Our next caller is Yvonne from Sunset.
Hey, Yvonne, how are you?
I'm doing good.
Is this you?
Yes.
Is it Yvonne?
Yes.
Okay, good. I wanted to make sure I had the right picture.
You have the right picture.
You and the bison. That is a good-looking statue. Where'd y'all get that?
I have no idea.
You have no idea? I'm
It's
gonna
just in the back floor and it's just sitting there.
Well, I may come read the plaque. Don't you think it has a plaque on it that probably tells?
Yeah, but I haven't really gone by. I've been busy lately.
Been busy lately. What have you been busy doing?
Studying.
Studying calculus, right?
Yes.
Excellent. Perfect answer. All right, here we go. I've got a limit problem for you. The limit as x goes to infinity. Can you read it? It's sometimes hard to see the exponents. X to the 5th minus 3x plus 7 over 9x to the 5th plus 4x minus 2. What's the limit as x goes to infinity?
What?
They like this kind of problem on an AP exam. There'll just be one of them, but might as well get it right.
I'm guessing 1 over 9.
You're guessing exactly right. Is she right, Jaslyn?
Yes, she
is.
is.
Right, because if the exponents are equal, you look at the coefficients. If you're going to infinity, x to the 5th is going to way outweigh this other. This is chump change over here, okay?
Yeah.
So x to the 5th over 9x to the 5th is 1/9. That's the limit.
Right. Because of the powers were the same.
That's right, because the powers are the same. They're the biggest power, top and bottom. They're the same. We can basically ignore these.
Right.
That's really what we can do. If the biggest powered x's are the same. They like this kind of problem, so we might as well get it right. True?
Yes.
A bell.
Yay.
Thank you for calling in. You guys call back.
Okay.
All right, bye-bye. Who's our next caller?
Our next caller is Hassan from Carter.
Hey, son, how are you?
That was nasty.
Pardon me?
Oh, how you doing?
I'm fine. Is this Hassan?
Yes, ma'am.
I'm Carter. Excellent. What's going on at Carter these days?
Nothing much.
Not much? Y'all
Just
win?
acting a fool.
What, who's acting a fool? Nobody I know, right? No calculus person. True? All right, I'm going to put a problem up that we did earlier, and I'm going to remind you of the answer, okay? And then we're going to work it together. Is that all right with you?
Okay.
All right. Let me get this C. All right, Hassan, this is that same implicit differentiation, and I'm going to remind you, I believe I'm right. The answer was 1 over 1 minus the sine of y. That was the derivative. I want an equation for the vertical tangent to the graph. An equation for each vertical tangent to the graph. Do you know what you're looking for, a vertical tangent line? Where are you going to find that? Where the derivative is what?
0.
0 on the bottom, right? That's what makes an undefined or a vertical tangent line. So what do you need to set equal to 0?
1 minus sine y.
Good job. So can you tell me the answer? What does y equal? Well, what do you want to do?
Take my 1 over first.
Okay.
Take sine over first.
Okay, that's a good idea. 1 equals the sine of y. Well, what does that tell you? What does y equal now?
Y equals 1 over sine, which is inverse sine 1.
Oh, now hold on a minute. Sine of y is a unit, so we're going to have to keep it together. What angle has a sine of 1? We're looking for the angle.
90 degrees.
Say it again?
90 degrees.
That's right. Tell me in radian talk and you're good to go. Pi halves is perfect. That's exactly right. Remember, that's a unit, so we can't separate it. The sine of y is 1. It's this angle right here, and you knew it was pi over 2. Be sure you're in radians, okay?
Okay.
We're all radians all the time, aren't we? Good job. Listen, thank you for calling in. You guys call back. Who's our next caller?
Next we have Franklin from Lincoln.
Hey, Franklin. How are you? I'm fine. Have y'all done the area between two curves?
I can't hear you.
Have you done the area between two curves?
No.
Not yet? Are you just making that up, or is it true?
Huh?
Are you just making that up, or is it true? I'm just teasing.
Hi, Gabriel.
Did you say hi? Did you say hi back?
He's messing with me.
Is he messing with you? People like to mess with you a lot, don't they?
Yes.
All right. Let's see. Oh, I'm trying to find a perfect problem here. Okay, I think I found a perfect one for you. Do you see this trapezoidy thing and this other thing over here? You see that?
Yes.
Okay, this is a function called f. I want the average value of the function from 0 to 6, and that's the whole unit here. That's all the way across. How are you going to find the average value? Do you know a formula for that?
The integral from A to B.
The integral from A to B
F of B minus F of A.
of the function. Let's go ahead and just do that for now. I know where you're going with it.
All right.
All right. And now, for the average value of the function, did you sing a song about that? Did y'all learn a song about that, Jaslyn?
Yes, we did.
Jaslyn's going to sing for you in a minute. Are you ready? Jaslyn, do you know the song? 1 over.
B minus A
There we
times
go.
the integral of the function.
There we go. Did she get it right? She got it right. Okay. Let's go back to the problem. So you need 1 over what?
6.
There we go. 1 over 6 minus 0. Integral from 0 to 6.
right.
Aren't you glad Jaslyn's here today?
Yes.
I am too. She's doing a good job. All right, now, here's the problem. I don't know what f of x is, okay? But I do have some geometry going on. Could you find the area under the curve using geometry?
Yes.
Okay, it's going to be 1/6, and what you're going to do is find this trapezoid and do what with this one?
Subtract it.
Subtract it. Very good. That's exactly right. All right, let me get where you can see it. All right, this trapezoid has a base of 4 and a base up here of, gosh, I'm having trouble telling. I think that's a 1. What do you think? That's a 1. And the height is 2. Can you see all that? It's a little hard to see those graphs, I know. So if you've got a base of 1 and a base of 4 and a height of 2, what's the area of the trapezoid? 1/2, good.
The height times width 2.
That's right, the height 2 times
1.
1 plus 4, base 1 plus base 2, right?
Yeah.
You're halfway there. You told me to take away the other one. Let's get it, see if you can see it. This is 2, this is 1, and the height is still 2. So can you tell me the area of that one? 1/2, 2, good, times 2 plus 1 is 3. Good job. So that's just a 3, isn't it? So I'm going to go back here and just subtract 3 so you don't have to worry about that. What's this equal?
1. 1.
That's right. And what's 1 plus 4?
5.
5 take away 3 is 2. And what is 2 over 6?
1/3.
1/3 is your answer for the average value of the function. That means if I drew the line about here, that's where all this melds out to equal out. The positive and the negative balance each other out. Good job. You just used your geometry, didn't you?
Yes.
Who was your geometry teacher?
I forgot.
You forgot. I won't tell, I promise. Hey, thank you for calling in. You guys call back.
All right.
Bye.
Bye, Gabby.
Who's our next caller, Jaslyn?
Our next caller is Ben from Bryan Adams.
Hey, Ben.
Hey, how are you?
I'm fine. Is that your real name?
Yes, that's my real name.
I was just checking to see if you were using an alias today, right? You
No,
wouldn't do
today.
that, would you?
No,
How's Arthur doing?
Too good.
Good. Did y'all work hard today?
Absolutely.
Of course, always, right?
Mm-hmm.
You know how to do the derivative of the inverse?
I can do that.
You can do that? Okay, good. Some people have done it already and some are waiting, so I just want to be sure. Okay, here we go. If f of 5 is 11, and the slope at 5 is negative 4/5, and f of g of x is x, what did I just tell you about f and g? If the composite f of g of x is x, what did I just tell you? They are
Inverse.
inverses. Very good. So I want the derivative of G at 11. Can you tell me that? There's not a whole lot of information, is there?
No, not really.
So what do you know? You know that the derivatives are what?
Inverse.
That's right, reciprocals, right? So what's the answer to this question? It's this one, just
5 over 4.
good job. If you switch x and y's, does it make sense to you that the derivative switched the dy and the dx? You know what I'm saying?
I know what you're saying.
Yeah, if you switched x and y's, that seems reasonable. You knew the value of the function, so you knew this was the matching point. This is the reciprocal point, 11, 5. You knew the slope, negative 4/5 goes to negative 5/4. That's a great problem. I think they may have one of those on the test, so I hope you get it right. I think you will.
Thank you.
Thanks for calling in. Who's our next caller, Jaslyn?
Our next caller is
Y'all have me.
Jessica from Skyline.
Hey, Jessica. How are you?
I'm fine. Wait, what? I'm sorry, I didn't hear you.
Have you done the area between two curves?
Yes, I have.
Let me show you your picture, Jessica.
Oh, no, please don't.
Oh, please. I would share a lot. That's a great picture. You look like you have a secret.
Yeah.
You have a
Is it
secret.
cool?
You do.
Yeah.
Wow.
Wow,
That's your
you look pretty
secret.
cool.
Great secret.
Yeah, baby.
Have y'all done the area between two curves?
Yeah.
All right, I want you to help me do this problem. We'll use our calculator just because I want to talk about some things on the calculator. And I'll put the calculator up on the screen after you've had a chance to look. F of x equals x squared minus 2x minus 2. And g of x equals x plus 2. And if we don't have to do everything, calculator.
Okay.
We're going to do this calculator friendly.
Right.
Have you got it typed in? X squared minus 2x minus 2 and x plus 2.
Okay.
I'm going to show my calculator. Let's see if I can make it show. All right. I'm going to do a zoom 6. Is that okay with you?
Okay.
And whoosh and whoosh. What's the first thing I need to do if I want to find the area between the two curves? What's the first thing I need to do?
Find the intersection.
All right, I'm going to hit the trace key, second cal 5, enter, enter, enter. Don't get close, you need to find out. X equals negative 1 is the intersection over here. All right, let's find the other one. Tell me what to press.
Enter.
Second cal 5.
Oh, second cal
Enter.
5.
Yeah, you're right, enter it. That's exactly right. X equals what? 4. Which curve is upper and which curve is lower?
The linear one.
That's right, the linear is upper. I'm going back to the paper, okay?
Okay.
All right, let's see if I can show it here. So it's going to be integral from negative 1
1 to 4.
to 4. Which curve
G of
comes
x.
first?
G of x.
G of x, x plus 2. Take away
F of x.
x squared minus 2. Oops, I left out my 2.
Just the facts, ma'am.
With respect to x, okay? You did a good job with that. I think we're have to go ahead and finish this off later, but we could do it by hand or we could throw it in the calculator. Remember,
allow me to demonstrate.
it's on the home screen. There's a problem with accuracy if you do it on the graph screen, besides which it's kind of hard to do on the graph screen, but on the home screen, you can do it. We'll do that next week as well. We'll talk about that home screen. Do your function integrate on the home screen for accuracy's sake, okay?
Okay.
All right. Thank you for calling in.
Thank you.
All of you for calling in today. And I want to especially thank my student host, Jaslyn, who spends Saturdays tutoring. You've done a terrific job. We have 2 gift certificates for lucky callers. Jaslyn has set up the machine. We're going to show over here. It shows we have and we have 2 lucky winners, so I'm going to hit it twice. Lucky winner 12 and lucky winner 3. Jaslyn, who is that?
Number 12 is Crystal from Carter, and 3 is Brittany from Skyline.
Carter and Skyline winning today. I'm studying. Jaslyn and I are wishing you a 5 on the exam on May the 3rd. Work hard so that you can celebrate when those results come in and spend that money you're going to make. Yay!
Hasta la vista, baby.
Alright, thanks for tuning in for today's edition of Calculus Live. We enjoyed bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We love to be able to show your face on television. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. For all of us here at Dallas Schools Television, I'm Daryl, and join us next week for Calculus Live, same time, same place. See you then.